All right, let me see if I can get the light somewhat adjusted. I think I've figured out a pattern that works. Let me see. Actually, that ain't too bad. So, yeah, of course they turned the light panel into here like it's something off the Starship Enterprise. I'm not complaining. All right, so let's get started. Just a quick, few announcements. First off, when it comes to attendance, since we're so sort of deep into the semester and with those card scanners thing, I still haven't been granted access. So just to keep things simple, I think I'm going to bail on using those to collect attendance. So we'll just collect attendance with the sign-in sheets like we have been. So as has been the case in previous weeks, at the end of class, there'll be a series of sign-in sheets at the back. Just put your initials on it, and that'll be fine. We'll keep the same pattern that we have been with our quizzes. So quiz 6 is going to be uploaded. I hope sometime today. I know here recently I've been getting them up like Saturday, Sunday, something like that. But I'll try and get it up as soon as possible. And again, that's going to close on Friday at 11 a.m. right before class. So everybody okay with that? All right, any questions? All right, so we're going to keep on with the same pattern that we have been. So we're going to start off with a faculty introduction. So our faculty who's going to introduce themselves today is a mechanical engineering faculty named Mehdi Ismailipur. He's somewhat new, started last year, but he's been a great addition to the team, and I'm going to let him tell you a little bit about himself. So everybody, let's give him a round of applause. Anybody have any quick questions? All right. Well, first off, let's give him a round of applause. I'm going to get our main speaker loaded up here in a second. One quick thing. So our main engineering program, because she is a graduate of our engineering program. So yes, you can get past us professors, we promise. And so I'm going to get her loaded up and turn it over to her. So everybody, let's give her a round of applause. Yeah. I'll get you loaded up. All yours.
Well, like you said, I'm Jessica Meadows, and I came here to Marshall. I graduated in 2013. Presentations were never my strong suit, so bear with me as we go through this. He basically just said to talk a little bit about what I do and who I am and give you guys an idea of what engineering's like. So my presentation is engineers, what do we really do? For my background, Jessica Meadows. I was a non-traditional student in that I was a stay-at-home mom for 10 years first. I had 4 kids, which now are 20, 17, 14, and 12. And whenever I decided to go to school, when I heard they were bringing back engineering to Marshall, I thought I'd love to have my own design, build, bid, construction company. So that's long-term goals. Maybe before I retire, that'll happen. But right now, I'm at Steele, West Virginia. I started Marshall in 2008 and finished up in May of 2013. While I was here, I was a big part of SAME and ASCE with the Civil Emphasis program, and was one of the first members of the Theta Tau colony that was started here. And in 2012 and 2013, one of the biggest things I did was the Virginia's Conference with SAME. And those were probably 2 of the best things I did while I was here. They were the most like what I do in real life now. For 2012, I was really involved with Concrete Canoe and the design of the shape of the boat, what we were going to make it out of. We built our own little pool so that we could sink it, make sure it floated. The one thing we did not do was try to paddle. So even though we had the best canoe, the best paper, the best everything, we lost every single race because we spun in circles. And then in 2013, I was co-captain of the Steel Bridge team, which we got to go to nationals. So I got to go to Seattle for the first time. That was really neat too. But both of these really taught me about everything from design to meeting deadlines, getting materials, working with vendors, finding a manufacturer to help me, weld up the bridge. That's how I spent my spring break that year.
And if you're interested, that bridge and canoe is still here in the Polar Engineering Building.
Yeah, and the big glass windows. You can see them from.
Big glass windows.
Yeah. So then after graduation, you got to get a job, right? So I was lucky enough to get hired pretty quickly over there at Special Metals in Altizer, just Barbersville area. And I worked there for like 4.5 years. They started me out as a project engineer, basically, and then shortly after we had some people move along in their careers as well, so they put me over capital appropriations and project engineering at the same time. But then I left there in December and started at Steele, West Virginia, which is just right here behind you guys, and I'm a staff engineer there. So one of the main points I want to make with this slide is that when you get into the job area, you will do whatever they want you to. You'll be whatever they need you to be. So while I studied civil and my main interest was in structures, I got to Special Metals and they said, oh, okay, well, fix the melt shop wall, which I found out was a wall that they had moved 5 times, and the drawings I had to dig for were from 1920 to find out what that building was really made of to be able to replace it properly. So being a historian, doing research became a big, clear thing that I needed to do. Another one was secondary containment and compliance. I don't know if you guys remember the big chemical spills they had that then changed all of West Virginia's laws for contamination and secondary containments. We had to put secondary containments on all of our storage tanks. So I got to learn a lot about new laws, legislation, what's required, how often they're going to come and check on you, and what happens to you if you haven't done what they say. I also had to relocate a hydrogen-nitrogen system, which was a security, homeland security thing. If we wanted to get too close to our fences, then there was a problem, and trying to find a good location for things like that. Just lots of rules that everybody seems to have. Then for our pouring bays in our melt shop, they wanted to have a new hydraulic system. So I learned all about hydraulics and how you needed to pipe it and valve it and get it to work the way they needed to. And then in Kentucky, they had a 10-roll large tube straightener. It was one of the biggest machines I've ever seen in my life. And so I got to do 60-foot piling down in the ground and digging holes and trying to make sure they were all shored up. So that's what I was really interested in, because I'd learned about a lot of that in school, but then actually doing it in the field, when you try and vibrate in Kentucky soils, the ground turns to soup, so you have to actually pile drive it in the ground. And it was a learning experience. But then one of the bigger projects I did was the West Pickle House refurbishment, and that's what these pictures are of. That's a building in special metals that is actually built inside out. The steel structure is on the outside of the building, and then the siding was on the inside. And as you can see in the top two pictures, the sides of the building had curves, and the peak of the building had a curve. So in this particular building, they had nitric acid, sulfuric acid, hydrofluoric acid, hydrochloric acid, and a 900-degree salt bath. And what I was tasked with was re-roofing this thing because the asbestos siding was falling in. So I got very involved in researching materials, what they can withstand, being able to actually secure something like this and still be able to hold snow loads whenever your roof is inside out. And what we ended up doing, I had hand-laid panels made to fit these curves that were quite expensive. Nobody liked me because it costs too much money. But our end product is here. With the inability to have lighting in the building because of all the acid fumes, we were able to use these translucent handmade curved panels to allow light to come in and the workers to be able to see what they're doing. So I really like that one. Like I said, they kind of put me in a capital appropriations role too, which is ultimately why I left special metals. In capital appropriations, you beg for money. Money makes the world go round. Your corporation has to fund you for all the projects you want to do. So I was overdrafting and submitting all of our capital requests. For every year we had an $18 to $25 million budget. And I also had to track and report to accounting, progress, spending, all that kind of stuff. And you might say, well, why they have an engineer doing that? Because to be able to justify, defend, and make other people understand what needed to be done, they needed someone that understood what was going to be done. So I spent about 3 years doing that, and by the end I felt like an accountant, so I came to Steel, West Virginia. So just in the 10 months that I've been at Steel, West Virginia, I've done several projects there too, and again, it's just the continuing learning process. One of the first things was drainage and paving, so I had to get really back into my books about slopes and how asphalt's laid, subsurface conditions, continue to learn about the Kentucky ground again. They gave me another acid enclosure, go figure. This one was a building inside of a building, so trying to logistically erect a steel structure inside of a building and then also put siding on it from the inside out has been a nightmare. I've learned how scrubbers work. I always knew kind of the idea of what a scrubber was, but not exactly how it worked. So got to learn that just a few months ago. While I was there in Kentucky, I was also troubleshooting bag houses, finding our P&IDs for boilers and heat exchangers, because all of our acid tanks there have to be heated, and they use the furnace heat to then transfer it over to the acid tanks for energy savings. Then there's small things like access stairs, you know. All of your stairs have to be at the same elevation, you know, 8 inches, 8 inches, 8 inches, so people don't trip. But sometimes people don't realize that. So they have us in engineering draw up and have made safety items like staircases, handrails, things like that. SPCC, planning and mapping, which is the spill prevention control plans of our facility. And so I have to go around and inspect those every month or so and make sure that we're following all of the rules and regulations of the government. And more recently, I have the EAF furnace back tilt, which this is a picture of it right here. Over there we have two EAF furnaces, or electric arc furnaces. Electrodes go down in, cook up the metal real good, get it nice and boiling hot, and then they tilt to pour it all out into a ladle, and then they tilt backward to get rid of the slag. So what our guys there would like us to do is help them to back tilt faster so that they don't get slag into their ladle as they're trying to pour out the metal. So it's back to research. I have to find out what's there, which they were built in like 1960. And single acting cylinders, you can't necessarily pull them backwards. So you have to change the orifice sizes, and I'm kind of in the middle right now of learning about the hydraulic systems on that thing so I can help them fix that. The lime silo distribution system, they came and said, we have lime silos that need replaced, but we don't want to put it in a bucket anymore with a fork truck and a guy. We want you to convey it in there and inject it. And so I had to learn about lime injection in a furnace. Why do you do it? What does that do to the metals? How much pressure do they need? Do we have the types of air pressure that they will require? And the more we find out, the more they don't really want injection. That's not going to work for our systems. So we're in the middle of talking with the department about what they really need right now. And then back to my civil roots is crane girder repairs and improvements. We had a crane girder crack last year, so I've been trying to beef it up some, redesign it, and since I don't have my PE, I send it out to a professional engineer to be stamped. So that's his pretty little stamp on my drawing over there. Just kind of, as a project engineer, if that's what you're going to be and do, there's several main steps to getting it done. Your first one is research, communicating with your client, understanding the problem, communicating with your vendors, understanding your quotes, making purchases, and then working around your production or your timelines that you have. So I'm going to kind of use the lime silo as my go-to for all of this, but everybody comes to you with an idea. So the first thing is research. I had to understand what the lime's used for, how they currently do their system. Are they wanting a new technology like injection? And how we're going to make that work with our system. And if you're trying to put in new equipment, where are you going to put it? Is it going to fit? And do we have everything we need for that? So like I said, you have to understand what people want. First thing they come in, so you got to go talk to them. What do you really need? What's going on? What do you want? Then what the manager wants isn't always what the operator wants. The guy that actually runs that machine is the one that you really have to make happy, because if they're not happy with it, they won't run it right. And they're usually the most knowledgeable about what really needs to happen in the facility. And then, like I said, you have to learn how it works today. I had no idea how metal melting and production and rolling worked when I first came out of college, but I've had to learn as I go. And like I said, they don't always understand the problem that they have. Sometimes they come to you with a thing that'll really improve their system, but it's not really what they need. And it can sometimes create new problems. What has happened in this particular lime silo, he wanted to inject, and so we're saying, okay, if you want to inject, we got to put a new panel on the side of the furnace, and we got to water cool it. And you're going to have to shoot it into certain locations so that it doesn't cool your pot down and ruin your furnace. And he's like, I don't think that's what I really need. That's going to cost too much. That's going to have too much downtime. Maybe we should put it in through the top. And we're like, well, putting it through the top isn't lime injection, and you don't need the pressure anymore. You just need air blown in to make things work that way. So trying to figure out what they really, really want. He just wouldn't want to have to use a fork truck anymore. He just wanted a conveyance system to get it in there. He didn't necessarily care about the injection and what that would do to his furnace. So once you figure out what your client wants, you have to talk to vendors and contractors. So most of the time when somebody comes to you with an idea, they've already kind of got it all laid out, and they're just going to hand you what they want, and you're going to get it for them, and it's going to be perfect. But it doesn't. So you've got to go back to the contractors and the vendors and say, okay, this is what we really need. Let's hone down our quotes and our scope and what you're going to provide and what we need. And you got to make sure you're kind of like a mediator. You make sure everybody knows what's going on and everybody is understanding of what they can and can't expect out of the project. But as you're doing all of this, oftentimes there's scope creep, which is where your project grows and grows and grows, and then you no longer have enough money to cover everything that everybody wants to do. So once you get all your quotes back in from everybody, then you got to go over every single aspect. You got to check all the equipment they're going to provide. Do we have the utilities that we need to make sure this is going to work? Are we going to have to do excessive maintenance on some of these things? Are they really robust enough parts to what we're going to be using them for? Are there going to be delivery, installation, and space problems? Some of these people don't think about that. With the lime silo, again, one of them proposed a 71-foot tall silo. How would you guys propose to get a 71-foot long object into the city of Huntington? I mean, we have viaducts, we have sharp corners. You're going to have a 100-foot long truck, and that's not really feasible, especially to get it behind Marshall University into our plant and into the little cubby hole that they want to put it in. So we've asked them to kind of revamp that, make it into two or even three pieces, and we'll construct on site because nobody had thought about how they would even get it here. And then are there safety issues? Are they going to be providing the handrail requirements and the everything? There's so many things with safety that are a problem. And then as well as during erection, do we have room to be able to tie everybody off? Are they going to be safe while they're out there? And then you just continually wonder, did I think of everything, which you probably didn't. So then you go into spending the money. You know, money makes the world go round, or it can stop your project. Restrictions and approvals and timing, that's all what makes everybody, you know, we got to get it done, we got to get it done, let's go, go, go. But making things go fast is not cheap. So whenever you're in the request process, sometimes you have to ask for a little contingency. Try and remember there are going to be things that are not planned for, and you're going to have to figure it out as you go while you're there. Digging is always the worst. I don't care where you're at or what you're doing. Every time I've tried to dig anywhere, we've run into old foundations from equipment that was there 30 years ago, and they just left it there. And I was just going to dig through some dirt, but now I've got to spend an extra 3 weeks chipping out concrete. Or running into old power lines, old gas lines, water lines. You don't know how many times water starts spraying out of the ground and everybody goes, oh crap. So those all add to your project cost and time. So then, again, with timing, it's about whenever you're in the steel industry, it's about production. Everything's about the almighty dollar. They got to keep running. They got to keep pumping stuff out, and they don't want to come down for you at all. So trying to be the master coordinator of everybody that has the time to be here and being here on time, ready to go, and getting it done quickly is really, really harsh. But inevitably, they always want you to do it on the weekend when they're down. In Kentucky, we have a galvanizing facility, and they run Monday through Saturday. They only want me to get in there on Sunday to be able to work on anything they have. But then they don't want to pay the double time. So that's never fun. So really kind of, I know this was really quick. I don't like presentations, but this is the end of it. What do engineers do? We do everything. We interpret what people want. We try and estimate without solid dollars. We have to look up buildings from 1920 to figure out what we need to do today. If you're wondering how in the world did that happen, they ask engineering to go figure it out. You have to make sure everybody's safe all the time. That's one of the primary things at Steel West Virginia. They want safety always. Can't be dumping anything weird in the river. So you always got to be conscious of what kind of products you're using and what kind of liability your company will have for that. along with the budgeting and everything. You got to make sure they've got your stuff on order. You got to find out if it's gotten here. You often have to go pick it up and get it to the guy that needs it in the right time. And of course, we're all draftsmen. That's one thing I did not get a whole lot of training in here was AutoCAD. We didn't do much AutoCAD at all, but I do a lot of it now. So if you ever have the opportunity to work on your AutoCAD skills, do it now. But ultimately, we're problem solvers. So no matter what the problem, engineers are what's it? Anyway.
Any questions?
You guys have any questions?
What other classes
Honestly, any class you can take. I know that a lot of times your schedules don't always coincide with the way they offer them. So if you come up with a semester where you really only need 2 classes, go ahead and take a couple extra electives. I did take fluid mechanics and hydraulics, but I could have used more training in that. At my time, thermodynamics was required for civils. I don't really use that. Heat transfer is not a big thing for me personally because we just say, hey, this is what I've got. Vendor provides us what I need. But if I have to redesign a cylinder to be able to back tilt faster, I really could have used more hydraulic training.
we since took thermo out, but you can take it as an elective if it's something there.
Yeah. Anything else?
Any other questions? Go ahead. What are some skills you use to balance? You had an interest in like how
Oh, yeah. Well, my worst semester, I took 21 hours. I had 3 labs. My youngest daughter was 4, and I cried every day at the end of the semester. I would not recommend doing that. The following semester, I took yoga, and that helped. But yeah, just try to, know your limitations. I knew going into 21 hours, it probably wasn't a good idea. But I made it, I came out pretty good.
I was going to say, did you have any other advice for them?
Clubs and networking. Seriously, like you said, you get out of college and your ultimate goal is to find a job. I found one like that before I even graduated because doing stuff locally. There's Engineers Club of Huntington here in our area, and that's how I got my job because Sam Clark was getting ready to retire from Special Metals. I'd been to several of the meetings. He knew me, and they kind of offered me the job without posting it. So, networking's good. And then doing things like the steel bridge competition, or you guys have a Baja car now for the mechanicals. That really helps. That means and tells employers that you've done something, you've tried something you understand and have worked towards something. Even if it doesn't win, it's at least you tried, So that's good.
Even the electricals have competitions of their own as well.
Mm-hmm.
Any other questions? All right.
All right.
Well, Susie, first off, let's give her a round of applause.
Thank you.
So again, just make sure, just like in previous weeks, make sure you sign in the attendance sheet. Quiz is going to close next Friday at 11. That's all I got. Y'all have a wonderful weekend.
I timed that just about right, didn't I? Oh.